Hi and welcome. This time around we have an interesting project from a customer of mine. It involves some procedures I haven't really done before, like broaching, square broaching. It's going to be broaching a really fairly large broach relative to the diameter of the part, and he needs 12 of these parts, so I have to think about things in terms of manufacturing, which is kind of interesting. But before we start there, I got a letter and some cool stickers from one of my viewers who actually has a channel of his own right, and he's actually a real machinist. His name is Max Grant, and you should check out his channel. He sent me a letter and a few of his stickers. Swan Valley Machine Shop, Perth, Australia. He has a really interesting channel, and if you want to see someone who can do pretty much anything, check out this guy. Entertaining and incredibly versatile. So, plus he's a multi-generational machinist, so he has a lot of experience under his belt. I pretty much watch every one of his videos because there is a lot to learn there, and for someone starting out like me, it is a gold mine. So again, Swan Valley Machine Shop, thanks Max for sending me the stickers. I really appreciate them. I just need a flat spot in my shop to put them because I don't have one now, but I intend to get one. Thank you very much. Now the project itself is pretty straightforward. It's some broached shims, and I have a scale drawing underneath this. I make it larger for my sad, tired old eyes. Here is a scale drawing of what the final dimensions of the part will be to scale. Pretty small, and you can see it, the broach is a substantial portion of the diameter here, which makes me wonder if I'll be able to pull it off, especially as with the limited broaching experience I have, but we're going to try it anyways. Since I have to make 12 parts, I picked up this Edge Technology collet stop for 5C collets so that I can do repeat operations on it. And the way this thing works is you pop in the, depending on what your final diameter is, let's maybe this size here, put in the stop, just tighten this down to set your depth. Probably will need to readjust that, but anyways, it screws into the bottom of your 5C collets. Some 5C collets, I'd say the majority, have internal threads, but not all of them. So if you're wanting one of these, don't just assume that your 5C collets have them. Check first. You just thread this guy into the bottom. You set your depth of your part. And every time you seat this, you pull a part in and out, it's going to push up against that. It will sit at the same spot. So here. Is actually a pretty tight collet here because this stock is a little bit oversized. It's instead of 625, it's like 627, so it's holding down. So let's say I wanted to leave it there. There you go. And I was thinking, I don't know what the experienced guys do, but I was thinking that since I was going to try for a specific depth initially, what I'd do is take my depth mic, put it across the face of this, set this guy to 1 inch here. The overall dimensions of the part are 1.75 inches. That would leave a little bit of stock sticking out to work on. So when I get this into the collet chuck, we're going to try that. However, thinking about the broaching in advance here, I think that if you were trying to just push on this brass piece sitting on a couple plates supported by the very edges, there's no way that's going to work. So I'm going to take this square chunk of cold rolled here, and I am going to bore a 5/8 inch hole down the center with clearance hole going all the way through for the broach, and that will provide a support for these parts as I try and broach them, and maybe that'll increase my chances of success. I know you experienced guys out there probably have all kinds of suggestions, and I can hardly wait to read the viewer comments, because I gotta say, I thank you guys a ton. I always learn something from everything you say. Even if I disagree, I think about what you're saying, and it makes me consider other options, and that's always useful, because being a machinist, number one is being versatile in thought, and you guys help me stay that way, so I really appreciate that, because you know, we can get stuck in our ways. So let's move on. So the first thing I'm going to do is put in the 4-jaw chuck on the lathe, and I'm going to drill and bore this guy for the broaching operation. I popped this guy in the 4-jaw chuck, and I got it approximately centered, but it's not particular about how centered it is, because it's not like this is fitting in a fixture or anything. This guy is just going to sit across a couple press plates. So I got it mostly centered so that it wouldn't be out of balance too far, and we're just going to drill and bore. Alrighty, we're through. So I don't have to use a tiny little boring bar. We're going to use a 9/16 end mill to get us close, and we will bore a final 5/8. The advantage of an end mill is it gives me a flat bottomed hole. Okay. Well, we were packing some chips there. Glad I reached the bottom. Alrighty. Last pass, we're going to take 10 thousandths out. This is the boring bar from Solid Rock Machine Shop. Two-sided, very nicely made. This is just cold rolled steel. Look at that finish. That is beautiful, isn't it? Quality boring bar. Quality insert came with the boring bar. Okay. Now the important part. Oh, okay. Well, that was good because that has almost no slop whatsoever. Yeah, that's really tight. So we are good here. We are done with the broaching block, which I will use on my hydraulic press when we get there. So this 5-seat chuck had been slightly damaged before. So what I'm going to do is I'm going to face off the chuck itself very lightly. I've preloaded it with some brass of the proper diameter so that it has something to push against, and I'm going to face it off. This way when I want to set my depth stop, I'll have something to set it against. So we just did some hard turning there. I might as well get the rest of the brass to match. I guess it doesn't really matter because I'm going to cut this off anyways. So what this hopefully did was give me a flat reference surface here, which it looks like it did, that I can take my depth mic and put it flat across here, set the depth reasonably accurately. And anyways, then we can cut some pieces and make some parts. I preset my depth mic for 1 inch and locked it off. You can see there. And then I pushed in the depth setting and till it touched, and tightened it. Try and do this all at one time. You can't do it in the chuck, I realized after the fact, because there'd be no way to get to the tightening screw, so I decided to preset instead, and we're right on. And just one more thing, although I really like Edge Technology stuff, my channel is not sponsored by, nor do they give me any free tools, unlike other channels. So if you're wondering, I'm not a shill for them. I have purchased every Edge Technology tool that I use. First thing I did was when I tightened the collet in, I put a mark on the little nut and the collet face so that I could line it up and tighten it to the same spot every time, which would put the collet depth into the bevel the same every time. Then I zeroed my DRO on the face here, which should be exactly 1 inch from the back. And then I went out 750 thousandths, which will be, and set my zero here, which will be the size of the part. So this one already has one side faced because I I had faced it on the other side when I had faced it when we were flattening this face out here. So I left extra material that I probably didn't need. I left a full 1/4 inch. I'll do less in the future when I'm cutting. This is just my first part, testing and setting my setup up. Alrighty, let's see how we did. Let's pop this guy out of here, measure him, and see if we came up on the size we were intending. Okay, the burr's on the outside, so it shouldn't affect my size measurement here. Shooting for 1.75, and it looks like it's 3/1000ths over. All right, let's see if we can dial that in. So really handy are these soft-jawed pliers. I got these on Amazon. There's the brand name. It's a Japanese company. Really handy if you don't want to mar parts. Now with the stop in place, I can pop this back in, and now I can move my 0 over 3/1000ths. I can tighten this down until it's snug and then make the blue lines match, so I know that I'm same depth there. So the blue lines match here. And we're going to go 3/1000ths under 0. Brass does cut wonderfully, but I will say one thing. It is messy as all get out. Okay, we'll way past center line there. All right. Let's pop this guy out and measure it again. I deburred it and taking a measurement here. And 7.7495, 1.75, 1.7495. I'd say we're well within that plus or minus 5/1000ths. So now we got the depth stop. So now if I wanted to do a bunch more of these, I could. I've got a 0 reference, and I can use it. Next up, I'm going to pull the stop out of there. Right now, this whole set of operations was just to see how much work it would be to reproduce this part in mass. So the next step is going to be to pull the stop out of there, and we're going to drill all the way through this part with the pilot drill size for the broach, and then we're going to drill in 3/4 of an inch with a drill bit that is clearance for the broach, because the broach is only good for a 1-inch total depth of cut, and this is a 1.75-inch part. So I'm going to pop this guy out of here. We're going to do the drilling operations, and then we're going to go over and broach it. One note here is that the depth stop's preset, so theoretically if I screw it back in, I should come back to the exact same point. These aren't multi-start threads, so I'm taking the same path each time. So now this preset shouldn't affect anything. All right, so we're over here at the hydraulic press, and I centered this a little bit worse than I thought I did. I mean, it was really rough, and I wasn't careful about it, and it shows. It's kind of still ugly. So I'm going to take the relieved side. I'm going to leave that up so that all the broaching is going to happen at the bottom where it's most supported. However, that will require, I'm going to use a pin to have to push it all the way down to get the broach to fall out the bottom. So we're going to preload the broach in here, and we'll get it set up over the hole like so. I can lower this guy down. I can move the plates over so that it's as centered as possible, much centered as possible. Reading up on this broach, it says it takes about 2,000 pounds force. Actually, the nice thing about this is I can totally fill this pocket up here with cutting fluid, and that'll lubricate the broach as it goes through. So now we're just going to push it down. It says 2,000 pounds force, which is almost none. I probably should use the air jack, although for this initial thing I'm not going to, because I want to feel for how much force it's taking to push through. I expected to get somewhat harder, but I think they've got the cutting force for every tooth to be approximately equal, so it really isn't changing as I go further. And we're through. All right. All right, so I had to switch cameras because it broke the camera. So I've got a, once we broach the part, then I can put it back in here with the depth stop, flip it 180 to get to the side where the broach is all the way through. And then, and this may actually end up being reversed. I put the relief on the other side, but I need to contact the client about which side he actually wants the relief on, because if the relief was on this side, the slot would have very little material. I'm sorry, not the slot so much, well, the slot too, would have very little material to bite into, and it would just leave a very thin rim around the outside. So I purposely did not do it that way. So we're going to set my 0 here, and the first 62.5 thousandths is the cutter thickness, and we need to go over 125. Yes. And I can lock the carriage here. And it's over 1/16 in a 1/16, so we're going to go quite a bit faster than that. And got to slit it. Okay, that's it. Last operation is take it over the mill and mill a horizontal 1/8 inch wide slot in it. So to get the square hole lined up with the ways here, I found this 5/16 tool bit, high-speed steel tool bit that fits nicely in there, and I silver soldered a piece of A2 hardening ground stock on it. I didn't get the orientation this way correct, but that wasn't so important. I just needed it to be flat on the surface. Then I took my indicator across it, lined it up, and now we are perpendicular. It wasn't critical, this measurement, at least on his drawing, but this will let me set it up pretty close every time. Next up, to find the center, I use the coaxial indicator. So now this whole base is centered over this, and I can zero my DROs, and I can keep coming back to 0, which is nice. I only have to do it once. The parts can come in and out and keep going. Alright, so here's the final part. Relieved side in the back, 1 inch of total depth, square broaching, left a little bit of radius on it, and slot like he asked for with the 1/16 of an inch deep, 16 inch wide, 16th inch from the center groove around the side. We should be good to go. I did the relief on this side just because it seemed like a better choice than this one, because that wouldn't leave a lot of material after the slot's in, but maybe that's okay. I'll have to ask him what he thinks, because I can easily put that on the other side. Doesn't really matter. That would give you more square broach length that's uninterrupted. Anyways, that's the final part. So I figured out my techniques for manufacturing these in quantity. So if he wants the 12, I can do it, and I'm just going to use the stop. The stop will help me set my depth for my part for facing. It'll also help me set my depth for the grooving operation. And the grooving operation should take place before the broaching. I did it after. Also, the grooving operation should take place before the countersink, because once you do that, the depth stop, the small depth stop, ends up fitting inside, and I have to recalibrate. But anyways, those are things I can work out if I get to production. I've got my alignment tool here, and it worked out pretty well. It was quick and dirty, just something to help me get a better a better lock on what I was doing. If I was going to do a ton of these, I would spend much more time and make a proper tool. This was just quick for this project. Anyways, I found it very interesting. I learned a lot doing it, and if I make 12 more, I'm sure I'll learn even more still. Anyways, hope you find it useful. Thanks for watching. Hope to see you next time.